Hey, good morning, everyone. Super excited for a very interesting conversation on the VM space and blockchain, or as Dimitri and I were talking before we started the stream, VM might not be the right word. Maybe it's more the execution environment space. But regardless, super excited about this conversation. So before we dig in, let's just do super brief intros. Jump right into the dense meat of the conversation. But yeah, just intros, who you are, what you do, and what project you're working for. Let's start with Kevin.
Yeah, so I'm doing all things developer relations for Monad Labs. Background was 5 years at Apple doing like low-level optimized systems for like audio, working on AirPods, and then I was a Solana core engineer for a while, working on the runtime. So I'm assuming that's why you guys wanted to have me on, because I have some experience with the EVM and the SVM runtimes both. So
Cool. Dimitri?
Yeah, so my name is Dmitry. I'm a historical co-founder of Fluent. So my main focus during my life is virtual machines. I love virtual machines and everything related to compilers, and work in blockchain crypto space for the last 10 years and more than 10 years with compilers, virtual machines, and etc.
Thank you. Rushi?
I'm Rishi, one of the co-founders of Movement. I'm super excited to be here, and we're bringing the Move VM to Ethereum.
Great. Awesome. And my name is Rex. I am the co-host of the Expansion podcast from Blockworks. And I think with that, let's jump in. So I'll ask our production crew to pull up a tweet right now to get us started. And let me read it to you. So Wei Dai in a thread, but we'll jump to tweet number 8, says, blockchain VMs. Let's face it, complicated algorithms or data structures are simply not feasible today on existing VMs like the EVM and the SVM. It's clear that application-specific L2s need better VMs. Projects to watch: Arbitrum Stylus and Fluent XYZ. So with this tweet as context, Wei Dai points out that today's blockchain environments are not supportive of modern computing. Do you guys agree with this view? And if so, can you help us unpack what feasible means and why we aren't there today? And if you don't agree with this view, what is the path from where we are today to supporting modern algorithms and data structures? So we'll just go in vertical order here. Dimitri, do you want to start us off?
Yeah, so I totally agree, actually. So my point is feasible stands for developer limitations. So what developers can build on the platform. And today, for example, developers, if they create something for EVM, they're quite limited technically with the number of instructions they can use, with the limitations of the stack. And by using altVMs or different execution environments, we can bring more efficient execution environments, more efficient VMs, and help developers to create more efficient apps.
Sorry, lost the mute button. Kevin, what do you think?
yeah, I think I'm like somewhat in agreement, right? I think like there's like multiple ways to unpack this. Like, so for one, like I actually do agree that the EVM as it exists today has some limitations. But I'm quite excited about EOF, which was just proposed in the next Ethereum hard fork, right? Which does actually bring the ability to like introduce like a lot more cross compilation like options, so you can support other programming languages. At the same time, I do think like developers think about blockchains like today in a slightly different way than I think they'll be thought of in the long term, in the sense that like a lot of developers are trying to do like everything on a blockchain when it's like a very specific tool. It's like when you look at like a GPU, you would never write your same data structures and algorithms that you would do on a CPU for a GPU, right? And so I think blockchains are a little bit like that. Like it is an application specific domain where like the power of the blockchain is the verifiability of something. And what that means is like to a developer, like your data structures and algorithms should look a little differently. Like I don't think you're going to want to do like a dense matrix multiply on a blockchain, right? It's not like a good domain fit. So I think there's like nuance to this. Like if you're just talking about like programming languages and the ability to like more freely express yourself in different programming languages, like I would agree. I think that like that will, you know, get fixed ultimately with some like advancements in compilers. If you're talking about like what you actually want to represent on the blockchain, I think it's a bit of like an application specific domain.
Mm-hmm. Interesting. We'll definitely come back to a few things you said, but Rushi, what do you think?
Yeah, I mean, like, I think inscriptions is the best example of this, where we saw pretty much every L2 go down like 100, 120 TPS, which means that's fundamentally losing the battle to layer ones like Solana, Mana, etc. And I think to even compete, we need to radically improve the execution layer. A single-threaded EVM cannot and will not scale, both from a throughput point of view that people have already touched on, but more on the security point of view. This 4.5 billion loss every year in hacks. If we ever want like anyone real to use crypto, we have to create more secure execution environments, secure principles, and it's only possible with customized VMs. The way I say it is like we spend a lot of time on modularity, like on DA layers, on role frameworks. That's like modifying the chassis and the brakes of a car, then leave a 1994 engine in the car and be like, why does the car not go? So the goal of everyone at this table is to improve the engine for crypto, which is probably the most important thing.
Yeah, I hear that. And I want to bring the conversation back to something that Kevin brought up, which is that maybe the frame that Wei Dai gives us like is looking at the problem wrong. And we shouldn't be looking at how do we jam like Web 2 centralized computing into blockchain environments. Instead, we should be looking at how do we pull apart like the pieces that should be optimize and involve blockchain and like optimize our systems for that, and then also recognize that there is a like large portion of compute that shouldn't be on blockchain. And so one, I would just want to hear if that resonates with you, if like that is how more applications of the future are going to be built. And so do you agree with that? But two, is the implication of that we need to worry less about the like speed and expressivity and like the bringing blockchain execution environments up to modern compute standards? Or like, I guess to rephrase, how does this insight inform like the design choices that you're making for your execution environment? So I'll kick it back to Kevin first.
Yeah, I mean, like, I do think like speed and scale are still needed. I think it's just like a CPU is still fast, even though the GPU is faster at certain things.
Mm-hmm.
Right. And they're both like fast machines, but you would just like never code the same way you would code on a GPU as a CPU. Right.
Mm-hmm.
And so I kind of look at blockchains like that. Now, I think like where I think we actually aren't actually all that advanced in blockchains is like the readability and accessibility of data on these blockchains. And I think that gets expressed a lot of times as like frustration with, the VM or something like that. But ultimately, I do think it's just like, blockchains are pretty much optimized for writing data, and they're not really optimized for reading data. They're more optimized for verifying data, but not necessarily like reading large amounts of data. And so like a lot of developers look at a blockchain as like a serverless setup for their applications. And I don't know if that's like ultimately the way it's going to work in the long term, right? I do think you still kind of need a back end to be like caching this stuff and like using this as like the verifiability layer. And like, sure, like it should still be fast and scalable. But I just think that like certain workloads are suited to like certain processors in different like places, right? And I think we see that in like modern computing today. So I don't know why blockchains would be super different. I do think it's definitely like a shift in how developers are thinking today, right? I think we like in early blockchains, we were like very excited about putting absolutely everything on chain. And you saw this play out kind of in the NFT craze of like last cycle where they were trying to do like all utility on chain. And like there are just some like not so great user experiences around that like might be improved in the future. And then you see something like a Farcaster come on the scene where they only put the critical pieces on chain. Yeah. Right. And all of a sudden people are like, oh, this is great. Like I'll actually use this app. And like, I honestly think that's probably the way we'll start moving like longer term is like, what are blockchains good at? Use it for that and like don't use it for other things. Because if you really are going to scale to like 100 million users, like even if each user is putting in like 1 or 2 transactions an hour, like you'll saturate like even like a high TPS chain at that amount of users. Right. And so, yeah.
Yeah, Dimitri or Rushi, do you have anything to add?
Yeah, so I want to add that blockchain originally is designed for verifying data. So as Ken has just mentioned, yes, you can easily upload and like compute everything, but it's most of the time very expensive to extract this information. And usually, yes, you can create heavy loaded applications and execute a lot of instructions, but you cannot persist most of state that is required for your app. So you need to find some sort of trade-off and split your application into two parts and keep one on the back end and verify the most important things on inside your smart contract, inside your on-chain computation logic. I see it's partially can be solved in the future by starting this modularity concepts where we can split the entire blockchain horizontally into different layers, where we can keep, for example, sequencers that are responsible for scheduling order of transactions inside blocks, or for example, even doing some pre-configuration, pre-execution, and with the execution layers that are responsible for computation, storage layers, data availability layers, proving layers. And in this case, you can focus because the CPU itself, it is designed and the computer designed with different components inside. You have a central processing unit. It is fully efficient for sequential operations. You have GPU that is efficient for several parallel operations, yes, but with a limited number of instructions. Also, you have RAM for the fast memory access. You have your SSD storage for a long-term memory access. And I think this is what blockchain should be in the future, where you can split the blockchain into different parts and optimize according to the specific hardware requirements. Optimize specific tasks, for example, for storage, for storing data, for executing, for creating proofs, because you can efficiently execute transactions on, for example, fast, easy on processors. For creating proof, you can utilize GPU acceleration. For storing data, you need a lot of very fast NVMe storage. So I think this is the optimistic future of the blockchain, and this is how potentially the problem can be solved.
Yeah, Rushi, do you have anything to add?
Yeah, I mean, like the whole thesis behind like modularity was to split up execution, split up consensus, split up DA. And in the past, we've never really seen the execution layer really be improved on at all. So I'm interested to see like how it plays out once we come to production, because now it's the realm of chain abstractions I've been spending a lot of time in. Because once you have all these moving pieces, like you have all these CPUs, you have all these high throughput GPUs, and then you have different execution layers, different sequencers. There's a lot of fragmentation that's obviously coming up. And I think there's a few teams working on combining all these different UXs with one deployment, with one SDK, with one L1. So curious to see like how the teams here work with chain abstraction protocols, if they think it's valuable in the near to midterm.
Yeah, and we'll move this conversation towards this like fragmentation issue in one moment, but I just want to put a bow on this last segment. And Kevin, you said something which is like I can't get out of my head, which is today the way that application developers look at blockchain is like this is a replacement for your servers, right? And I think that is the paradigm that we need to step away from, because like look, like if we want servers, they're like much more performant, much easier to use, much cheaper ways to get servers that you don't have to manage, right? It's called AWS. And so like we need to like take a step back, go to first principles and say, what is interesting about blockchain? And we've said it a million times already, right? It's about this verifiability and the trustlessness that comes from that. And so the questions developers need to be asking are not how can I put my application on this serverless server? It's which pieces actually need this trustless trust and which pieces don't. And then how can we design a system where only the pieces that need the trustless trust are interacting with blockchain, and the pieces that are performant and cheap and like don't really require trustlessness should be built the traditional way. So I think that's a good pivot point. And I do want to like start moving towards this conversation that Rushi was talking about, which is the fragmentation, right? But fragmentation second. First, I want to sit in the developer perspective and like really think about what questions I should be asking when I select an execution environment. So if I have an idea for an app, let's say that this concept could work equally well anywhere, like maybe it's not liquidity dependent or whatever, and it could be deployed on any VM. What are the types of things I should be thinking about when I make this decision? And I can put up a few things that I would be thinking about, but in lieu of that, let me just kick it to the panel. So Rushi, let's start with you. Like if a new app or a new DApp developer comes to you and says, like, help me understand the questions I should be asking, what would you tell them?
There's a few main things. Like, question is, I'll start off with like what you're building. When you're trying to build an app, you shouldn't be honestly caring about the two intricacies of the infrastructure. You just have an RPC that's fast, that's good UX. You should have trust that the infrastructure you're building on is secure, high throughput, generally good performance, and obviously have the support from the team. So I think the first starting point is like, what's the use case, right? If you're building like a yield aggregator rollup or something that's not really requiring a lot of throughput or, doesn't need a lot of performance. So off the bat, it's like a yearn, maybe like a Uniswap, like OG DeFi work. Maybe it's like, I'm trying to think. But anyways, apps that don't require a lot of throughput. That's stuff that you can use like the traditional EVM. You probably don't want to experiment too much. You can just deploy in base to have pretty good infrastructure. You don't need to get too experimental. I think where it gets interesting is where you want to bring on these new on-chain apps where it's like a fully on-chain MMO, a fully on-chain order book, things that require 10,000 plus TPS that you can't do on base, Arbitrum, etc. That's when you take more of the gamble, because it's really easy to just deploy an existing infrastructure that's been around for years, that has Lindy effect, has RPCs that have been around for years. But deploying new chains, obviously, is a little bit more of a gamble. So the question is it worth taking a gamble first off? In most cases, I would say the next wave of apps, yes. If it's like social, consumer, anything that requires more than 10 users, you need to have infrastructure that enables that. So then once you get to this category of needing high throughput infrastructure, there's a lot of like parallelized, high throughput, fast chains. Question is what chains do you build on? And I think that comes down to a few different factors, like support and relationships with existing system. Like if you're personally friends with Monad, friends with Movement, it probably makes more sense to work in that within an ecosystem just because you have the existing relationship. But if you're a new person coming to the ecosystem with no context, I think it takes a step to just talk to the growth teams and talk to the DevRel teams and understand from their point of view what makes their chain unique. I think for us, it's like really focused on the smooth language, on the security benefits, on living on Ethereum, as well as having the high throughput aspects. Whereas other chains like Fluent, you're working on different programming languages. So if you're Rust-based programming and you want to interact with Solidity scripts, it makes sense to deploy on top of Fluent. So it kind of depends on your use case in that sense.
So, man, I don't want to please push back if this is a wrong understanding of your answer, but to me, what it sounds like is you would suggest a developer does not make a decision based on the execution environment. Like you would make your decisions on on different things, whether that's like the community that you're a part of or the infrastructure or like the cost structure or whatever. But what I heard from you in that answer was not about developers should be first and foremost thinking about which execution environment my app goes into.
Yeah, it shouldn't, because in this lens of 3 years from now, there's going to be a bunch of parallelized L2s, L1s. I think we've all seen the one parallelized gets spammed out to oblivion. Thanks, Kevin, for that. But anyways, there's a bunch of high throughput chains coming to market in the next 34 years. They're all essentially going to promise the same 10,000 TPS and claim that they're solving cancer. But in reality, they're infrastructure is getting to the point where it's pretty good, right? So now it's about go-to-market, about how you can use infrastructure, and you need an ecosystem and community that can help you there. So I think execution layer is probably a third question you ask yourself after okay, what am I building? What's the community like? And then how can this execution layer and tech stack help me scale?
Wow, interesting. I would not expect that from you, Rushi, whose company is built on differentiating themselves at the execution environment. But Dimitri, what do you think?
So this is a good question, because of this question we started developing Fluent actually, and the question I'd answer developers as a developer is what I can get from the platform I use to build my product. Is it liquidity if I want to build some sort of DeFi application, or I want to have a shared liquidity or from, for example, and shared from Ethereum, from other layer ones? Maybe I'm looking for tooling compatibility. Maybe I'm looking for developer friendliness. But actually, if I'm developer, why? So why do I need to make a choice what platform to use and what language to use? So I'm a Solidity developer with quite big experience, let's say with 10 years experience. I like Solidity and I want to develop applications on Solidity. But and I have not much choices what platform to use. So I can only be an EVM compatible and use a platform that only EVM compatible and supports Solidity, of course. Yes, you can theoretically go with Solana by using Solent compiler and deploy your Solidity application, but it's still not fully compatible, brings some limitations, additional constraints. So I might be aware of all these limitations, and I need to know how to handle all these limitations in my app's logic, because it can bring a lot of significant vulnerabilities in my development, and it can affect actually development experience. So in Fluent, we like to developers to ask the question, why not the specific platform? So not the platform you want to choose, but why you don't choose another platform. So you're a Solidity developer and you want to create Solidity app. So I assume, according, for example, to maybe to fees policies and something else, you choose EVM compatible chains. But for example, you also can choose Fluent because Fluent brings EVM compatibility. Let's say I'm a Rust developer and I also want to create an application that runs on Rust languages. I can choose, let's say, Stylus. I can choose Solana. And but I also can choose Fluent, because in this case, if I choose Fluent, so I loses nothing, because for me there's no difference what platform to use. It's fully execution environment compatible, and I can deploy my application on Fluent. And without affecting my developer experience, I get much more benefits comparing to if I run on the original platform, because for EVM I get lower fees. I get fast execution environment because it is SDK based and it's semi-centralized solution. For Solana, I can do native composability with EVM apps, and I can create new types of apps on the edge. And if I'm not aware of all these technology-specific things inside Fluent, it's not a limitation for developers. They don't have to know all this, because they can still experience the same development experience and use the same tooling and run the application, for example, on Fluent, and share execution environment between but with other execution environments. So also as a developer, I'd answer the second question. So how I'm going to settle? Because settlement is quite difficult. I can use, for example, risk zero. I can use Delphinus Osmo, and I can use, for example, OP Stack and or some other solutions to settle. But in most of these cases, I need to worry about shared computation, how to calculate the proof, how to settle the proof, how to verify the proof, etc. And since Fluent uses some sort of like intermediate representation, ZK-optimized intermediate representation binary file, and I can easily translate my application into this representation and get a verified proof automatically. So yeah, in this case, for me as a developer, I get ZK verification settlement for free, something like this.
Mm-hmm. Yeah, it makes a lot of sense. Kevin, do you have any thoughts?
Yeah, I mean, so like typically when I talk to a blockchain app, like looking at multiple blockchains, like I really actually focus on the product, like what product they want to build, right? And then like for that product, there's usually like a set of convenience features that will make a difference, right? So it really depends on what that product is, but like let's say it's something that like I want this to be normie facing, so I don't want my users to have to like have a seed phrase, be crypto native. Like I'm really targeting like a Web2 user base, right? Then you look at like what things exist, that would make that easy, right? And like for all intents and purposes, like account abstraction is kind of the canonical thing. And that exists in various forms in different VMs. And so at that point, I think it really comes down to like how easy it is to like get access to certain features, right? Like how easy is it to like use a privy or something on this VM? Like how easy is it to, you know, get proofs, you know, like maybe I want an auxiliary network. Well, guess what? Like majority of auxiliary networks, their proof of concepts and their SDKs are like built for verifying proofs on an EVM. Right.
Yeah.
And that's kind of the reality of like any of these auxiliary networks. Like most of the examples and most of the research is centered on like actually proving back or settling on an EVM. And so being in an EVM environment, right, you kind of get access to those things. Another thing is like, even for like in the account abstraction case, it's like, okay, maybe I do want to use account abstraction, but like gas costs are too high, right? So you haven't seen a lot of account abstracted stuff on EVM mainnet because it like actually makes the transaction itself so complicated that there's like a cost to it, right? So really, I kind of just go back to like centering on like, what is your product and like, what are the things in that product design that make your life easier to like get to product market fit, right? And does a chain or a VM like offer easy ways to integrate or use those things, and do they not, right? I think like one example I'll just call out because I think it's pretty obvious is Solana has done amazing at this, right? I think things like blinks and compression, you know, a developer coming to Solana, they look at that as part of Solana, the developer platform, not as like some like separate piece of infrastructure that they have to go use. And I think like actually making SDKs and integrating, you know, like literally just building a JavaScript SDK so a developer can access these type of like networks and auxiliary things easier is actually like a bigger moat than most people realize. And I think that's something that like all of these ecosystems could do better at, right? Is just making developers' lives easier so they don't have to deal with, you know, analyzing 10 different solutions to do the one task that they want to do to bring their product to fruition.
Yeah, you know, I have to say, like, I'm a little. I listen to all three of you talk, and like I'm on board. But walking into this conversation about EVM versus alt VMs, like, I was expecting to have like some like real strong takes on like why a specific VM is the right choice for like maybe specific applications or new app developers or something or whatever. And like what strikes me about this part of the conversation is all three of you said essentially like the question shouldn't really be about the VM. Like the VM is an enabling tool that's under the hood that, like, as Kevin said, may or may not have like the right specific features. As Rushi said, like may or may not be fast enough, or as Dimitri said, is like easier not to deploy code. But none of you said like, hey, if you want to build applications, the first choice you need to make is which execution environment. And I think that's interesting. I think that that kind of like lends towards where we're going, where all this stuff is abstracted out, not only to the users, but even to the developers as well. And we'll end this conversation talking about that a little bit with what Fluent's doing and what's going on with Arbitrum Stylus and that kind of thing. But while we're in this part of the conversation, Rushi, I promised you that we talk about fragmentation. So there are so many conversations right now in crypto, and especially in like the modular world, about fragmentation. And like the obvious easy ones are like liquidity, users, like those kinds of like super metric facing issues, right? My question for you guys is, are we creating another layer of fragmentation at the execution environment space that is going to end up causing a lot of like headaches that need to be worked out, in the same way that like the roll-up driven roadmap created all of these like liquidity and interoperability headaches that we're just now starting to work through? And yeah, I guess that's the question. So we'll go in clockwise order. Kevin, what do you think?
Well, you know, we're a monolithic L1, so obviously we like, I think at some fundamental level, like we kind of believe that like while the you know, fragmentation problem may be solved in the future, it's nowhere near to be solved at any like usable level in the short term, right? And it's not that you can't build an L2 on Monad, like you could. I just think they look and they feel and they act a lot better for logically separated use cases. Right? If you don't need to compose with the rest of the ecosystem, then it makes sense to be on a roll-up. I don't think anyone would dispute that. But like generally speaking, for like tapping into, there's also just like network effects that build up around things, right? Like if
Right.
everyone likes to use a certain NFT marketplace and there's 10 rollups and it only, supports 3 of them, like necessarily like the people, the users of that app, the marketplace, are going to go where that marketplace is deployed. And if you're in this situation where for every, hit app, you have to like kind of decide where it's going to live, I think it adds a lot of like community scaling overhead. I don't even think it's technical for the most part. It's just that like people can only pay attention to so many things at once. And the more you fragment that across like different ecosystems and different silos, I think just like the typical user doesn't have the patience for it. Like bridging to another blockchain, quite frankly, is like the overhead of signing up for another credit card, right? Like if you talk to someone, that's how they feel. They're like, oh God, now I have to do this and this and this. And even if it really is actually easy, like the psychological like overcome of that, I think is bigger than most people like realize. Right.
Yeah. Well, and sorry, just to be more specific about this question, do you think that the introduction of all of these like very exciting alt VMs create a new dynamic to fragmentation, or do you think that whatever is being expressed in this fragmentation of VMs was already kind of encapsulated by the problems that we're dealing with at like kind of the user and the application level?
I think the latter. I mean, you kind of saw it from all of our answers to like the last question. It's like at the end of the day, like the VM is some level of decision, but I don't think it's like the major level of decision. I think it's actually like the features that you have access to on that network, right? And so like, yeah, I mean, like as much as like I think it can matter at some level, like for very particular apps, I think for the majority of them, it's more about like community and network effects. Like it's very like blockchains at like a very fundamental level are social networks. They're not actually technology networks. Like there's a reason Bitcoin is a cult around like Bitcoin maxis, right? There's a reason we have maxis of networks, right? Because like these blockchains have an identity and it's like actually like a physically social identity. And I think that's like kind of underestimated in a lot of these like technologist type views of blockchains, is that like people are going to have like emotional connections to these networks because it is like social formation of capital and different things to like bootstrap any of this. And so I think like when you realize that, it's like the fragmented ecosystems like face challenges that like socially I don't know where we can attack how many people there are on chain. There's not many people all fighting for the same people.
Yeah. Yeah, sorry, your audio cut out a little bit there, but I think we got the like the message that you're saying, which is I'm asking a technology question to a social problem, and like that's the answer. Let's hear from our resident Move Maxi. So Rushi, what do you think? Is the introduction of all these alt VM creating a new dynamic of fragmentation, or is this just the same shit, different day?
I don't think it's creating new dynamic fragmentation. Like the thesis was, there's always going to be L2s. Like the thing is that everyone, I tweeted about this the other day, is like everyone wants to be the L1, L2 to rule them all. Everyone's claiming that there will be this bad chain thesis and all value accrued to their chain. But the issue is that there's like 8 chains doing that, right? So when you have like 8 to 10 chains and then there's more venture backing for the next 5 more chains, it kind of gets difficult because everyone is claiming they're the chain to rule them all. So then it gets like, okay, if the current environment is that there's 10 plus chains that all have ecosystems, you need interop, you need chain abstraction, you need the ability to unify state. That not because I like that, I'd rather there be 1 or 2 blockchains that win, but beyond my liking, there is going to be 10 plus blockchains that exist, and that's the reality. So accepting the reality of saying, okay, let's work on building better interop methods and better sequencing methods, so that if I am a user, I don't have to get screwed by the 10 plus chains that exist. I can have a seamless UX where I can sell across multiple chains. So yeah, I'm looking for a few teams that are working on chain abstraction. And I think that's what comes up next.
Yeah, cool. Dimitri, any thoughts on fragmentation, or have we beat this one to death?
Yeah, actually a lot of thoughts.
Great.
So the first thing is fragmentation is fine. Yeah, fragmentation is what we have everywhere, and I don't see fragmentation to be a problem for blockchain, for developers. Let's say, let's move away from blockchain. Let's start with programming languages. Like, how many new programming languages appear every year? A lot.
A lot.
Do we actually need all these programming languages? If these programming languages are getting adopted, then we need them. The question is why these programming languages are getting adopted. So it's a good question. Google tried to force Dart language several times to replace JavaScript. Yes, it didn't work. What to do? They will try one more time. So Apple invented new Swift language to improve and simplify development of mobile apps and also to drop off Objective-C. Like, actually, why do we need all these languages if we have C? So you can develop any application using C. You can, okay, C++ is enough for all. Yeah, but it's not a problem that we have the tens of thousands or hundreds of different languages. For example, because we have such tool set like LVM, low-level virtual machine, that is developed by Google and Apple. So it is a standard today to be LVM compatible language. So if you're LVM compatible language, you can translate your language to most of existing hardware execution environments like CPUs, virtual machine languages, binary formats, and all the things are supported by LVM. So you only create one compilation target to a special magic so-called L language, and then you can translate it to any language you want. So if you run RISC-V VM, then by default you have compatibility with all LVM compatible languages. I think there are maybe 30 or 40 languages that are compatible with LVM today. If you run, for example, WebAssembly as a virtual machine, you also getting compatible with all these languages by default. There's no need to change anything. Like, by default, you only developers use their common compilers. There's no need to modify it anyhow. And I think this is a really right comparison with LVM, because actually there is a compiler. We have a compiler that can translate everything to one unified format. And in blockchain, we can do the same. We can create an execution platform, and any applications, any contracts can be translated down to one execution platform compatible format. So developers can use any execution environment. For example, they can use any language, and they all can run on the same big shared execution environment. Technology changes every day. This is quite obvious. And of course, you cannot create a technology that will work, for example, in years, in days. Like, you cannot predict what will happen in computer science, what will change in the way how humanity do computations on CPU and GPU. Maybe they find a brand new way how to execute applications 10 times faster. Then all your virtual machines will become to be useless, because you can create one more new virtual machine that can replace all these virtual machines together. So this is why I say that fragmentation is quite natural way to progress and to change the entire development environment. Because by doing this from year to year, we can find and create a very limited number of computation standards that fit all requirements that are required for blockchain needs, for ZK computation. But it will take a lot of time. Yeah, that's true. It can take 100 years. What to do?
Yeah.
Can I hop in here? Because I have a little bit of a corollary. Yeah, I actually think LLVM is an awesome example, because all of these languages target LLVM, right? And I kind of look at blockchains somewhat similarly, in the sense that I kind of look at ZK as what's going to be LLVM for us. It's it's not going to matter. At some point, you'll produce a ZK proof and pass them between. And so on the interrupt side of fragmentation, I actually think it's not an issue. Where I see issues is more of the latency side of things. The reality of making ZK proofs interop with each other right now is you're looking at multiple seconds between interactions between blockchains, which for a user and a consumer app, they've done studies, and I think you have 400 milliseconds between for between like a user's attention wanting to go to another screen. And so in my mind, it's less about like whether interop will be solved and more about like whether the latency of these interop solutions is low enough to like be usable as a product. So yeah, I just think that's like farther out than we expect.
Yeah, that's a great insight. And had I a little more forethought, I would have had a section in here about pre-confirmations and like what they mean for execution environments and ultimately if they solve this latency problem. But the hour's drawing close, so we won't go down that rabbit trail. But just to put a bow on this conversation, I have really believed that if you think like something unique and like never before seen is happening in blockchain, like that's how I can tell how young you are, because like there's corollaries in everything happening now that happened in the development of the internet. And so like what when I was getting my computer science degree, like I was there studying a little later than like when PHP was in vogue for creating websites. Like my time was Django, or what was it? Python, Django, and like Ruby on Rails. And then like now we're in this paradigm where it's like Node.js and like all this like JavaScript based stuff. But all of our websites talk to each other, even though like, let's say Nationwide has not upgraded since they first built their website in 1995. And my banking app that's like a new 2024 bank, right, like was built with like the most modern technology. Because all this has been abstracted away, like whether it's like directly because we have compatible binaries or we figured out communication protocols or whatever, like the internet works cohesively. And I do think that that's where we're skating towards with like blockchain. We're just not there yet. So to wrap up this conversation, I think we need to like talk about this new paradigm that the Fluent guys have named blended VMs. I love that that concept. But just real briefly, so projects like Fluent and projects like Arbitrum Stylus, they abstract away the VM to allow developers to write code in the language that they're comfortable in, and then ignore like the gritty inner details. They can just write Solidity code or Rust code, send it to the compiler, and the compiler does the job of making all these binaries compatible in like under the hood, right? So my question for all you guys is this paradigm the future of blockchain execution environments? Are we gonna see basically every successful blockchain execution environment support multiple languages and paradigms and thoughts, or are we going to continue down these like hyper specialized like EVM move SVM like vertical environments? So Dimitri, I will let you start because you gave us the nomenclature, but I'm assuming you think that this is the future of VMs, but can you just like kind of extrapolate a little bit more and tell us why you think that this is a good bet for you guys?
Yeah, so what we're doing in Fluent is we're trying, as we discussed before, we're trying to solve a fragmentation problem. But by trying to solve the fragmentation problem, we actually increase the fragmentation problem, I guess. The same problem that happened with compilers in the past. But now today, this problem is solved. So because developers can rely on one stable technology. So actually, before talking about this, I want to mention that originally, so blended execution is just a derivation of the another technology that we have. We found blended execution when we tried to optimize and simplify ZK proving process. So we wanted to create a virtual machine, again, a virtual machine that can be used to prove as much state transitions as it possible. And we figured out that we can create functions that represents functions and et cetera, And we found that you can create a function that represents everything because you can develop these using Rust language. If you develop these using Rust languages, so most of libraries are using Rust, and developers can just use it. So answering the question, is it possible today, for example, to use EVM to solve to fit all developer requirements? Yes. Is it efficient? No. So by implementing this blended approach, we want developers to be able to use technology they want efficiently. So for them, there is no need to worry about, how to migrate this library to Solidity. It's not efficient. I need to create all these wrappers. No. We want developers, we want to make the execution environment compatible with developers. and even more. So we of course we say that we blend EVM plus WebAssembly, but actually we don't have EVM support. We achieve EVM by creating embedded execution runtime inside. So we embed, we blend EVM inside WebAssembly, and we create just a function that simulates all Ethereum standards. And it's actually a reference to Ethereum standards because you have like tens of different, actually hundreds of different Ethereum standards, all these EVE standards, and you need to support this. You need to upgrade chain, and the legacy that you have, actually EVM is a legacy because when EVM was invented, there wasn't any like good examples of efficient execution platforms. They're trying to solve it with EOF formats. Actually, our binaries are EOF compatible with our custom segment structure, but okay. And the problem of all these problems, the problem of all these problems we have right now is legacy. Is legacy that we and it's an inheritance of the decentralization problem, because decentralization stands on the top of verifiable computation. So you must be able to verify all computations. So, but using Fluent, you can move all this upside down, and you can use, for example, our execution platform to prove correctness of all EVE standards. So you can make all execution environments forkless by default. And if it happens, since you run ahead of time compilers or just time compilers, you can anytime replace your virtual machine. And if something changes, for example, in the computation environment, something I mean in the hardware computation environment, or you have new ways how to compact execute binaries and like to solve like somehow to solve these tricky things, and you can just replace your virtual machine. And using blended execution, you can achieve this. And since it is layer 2, you can run it on a specifically optimized hardware that works, for example, in GCP clusters. You still can create ZK challenges to verify correctness of all these computations. And I think this is the future where you can solve so-called decentralization problem, because blockchains exist today because of decentralization, and this decentralization is the biggest problem of blockchain that limits its throughput, its how to say the way how developers can interact with the chain, because you need to do double checks of all these verifications. You have huge latency for the block execution. It also limits your interop. But if you run everything on the hardware optimized solution, then you solve most of these problems, and it is possible because of ZK. And yeah, so that's my answer.
Yeah, awesome. And as you know, and I'm hugely bullish on this blended execution. I think like it just is the answer to a lot of like the problems that we've discussed and the problems that we're seeing. But I'm curious for you, for Kevin and for Rushi, what do you guys think? Like, is this the future of how execution environments are going to look, or do you believe that like the what it's really going to look like is a bunch of different silos that are connected through these like interoperability services? So Rushi, we'll go counterclockwise.
Yeah, I think like the end game is where you have a bunch of different VMs that coexist. So you'll have like the Move VM, the SVM, the EVM, all coexist with their respective apps. The main challenge and hurdle will be on the interop standards, whether it's shared sequencing that has been explored, whether it's like ZK bridging and ZK like light client installations, whether it's like actual third-party bridging like layer 0 wormhole that gets better. I think all these VMs coexist. They all will have a share. Probably only 2 or 3 VMs exist in the end game, and then they all have interop standards, so people don't even know they're bridging between like SVM, Move VM, etc.
So to be clear, you don't really see like the inevitable future of blockchain execution environments as like these blended VMs that take in, things from all these different paradigms that we're inventing today and execute them in one execution environment.
I think that's the ideal like scenario, but the thing is that token saying it's very difficult. Like I'm excited to see what Fluent does, but like I don't know how performance changes that when you have multiple VMs with multiple languages in one VM. So I've yet to see that in production. Maybe Fluent and other teams prove me wrong, but I don't see that today.
Yeah. Well, we'll let Dimitri have the last word on this, but Kevin, what do you think?
I think it's kind of a nuanced question in the sense that like a VM is different than the programming language.
Mm-hmm.
So I think like a single VM can support multiple programming languages, and I think you will see that happen for most blockchain execution environments, just because like we have to get to a point where you can code in basically any language on blockchains. Like I think that's inevitable. On the VM side, like will the VM actually be like two VMs running in parallel versus one that supports like multiple programming languages? I can see it going multiple ways there. Like I actually think the Fluent approach is kind of smart in the sense that like ideally if you're gonna have multiple programming languages, you want like a single VM that can just like crank the different VMs through it, right? Like a more general one that can just like crank generic instructions through it and simulate these other VMs. That's probably the most efficient way to implement it. As far as like whether that base VM looks like, you know, an EVM or an SVM, or like the account models are different.
Yeah.
Right. And so even if you can like code in, you know, Solidity on Solana right now, you still have to conform to the SVM account model, even with Solidity. And it's the same the other way around. Like even if you want to do Rust on the EVM, like you still have to conform to the EVM's account model. And so I think it's kind of a matter of like, what's the most efficient? What's the most like way to get there? Is it just like enabling other programming languages on a single account model, or do you like actually want to support both account models? I think the latter is a much bigger ask and is probably not as feasible in the near term, because then you like you can think of like your computer as having like so many lanes as in like cores, right? And like so like in a parallel VM, like we're actually running like multiple executors of the EVM in parallel. And so for any other VM we wanted to run, like we'd have to give up some of those lanes to like put this other VM on, which is okay, but you reach a point where like if you want similar throughput for both, you actually just have to like double your amount of cores in the machine, which may be more attainable for like an L2 where you don't really care about like your node size. But for an L1, like you're getting to levels of like, okay, like now you're actually compromising on decentralization and stuff and like feasibility of running a node. And so I think it like at that point, you much more looks like, okay, let's use one VM, but enable all programming languages rather than using two, right?
Yeah.
Because there's like a limit to the actual hardware resources you can run these VMs on.
Yeah. No, I hear you, man. And we could go on and on about this, but I want to keep this to our allotted time. So as promised, Dimitri, do you have any like final just reflections or thoughts or just responses to what either of these guys said about what I believe is the inevitable future of blended VMs?
Yeah, I want to respond to Kevin and Drusha. So start with Kevin. We all call this VMs, like, you know, EVM, SVM, but these VMs are actually not VMs. Someone forced us to call them virtual machines, but the problem is that the definition of virtual machine changes, let's say, every day. It depends on the topic you use to highlight this term. So if you discuss it from like product perspective, you have one term. If you discuss it from technical perspective, you have another one, term. And if you discuss it from blockchain perspective, you have a brand new term, because EVM is not a virtual machine, because you cannot execute EVM instructions without violating Ethereum standards. You must follow all EVM standards Ethereum has. For example, how you execute, let's say, I don't know, balance instruction. You can't violate Ethereum standard. Of course you can, but then you're not EVM compatible, because EVM is not only about your instruction set, it's also about your execution environment. And as you mentioned, for SVM, it has the same. SVM is a standard that defines how you fill your inputs and outputs using special loaders. So you need to create a loader that is compatible with SVM standards. And in Fluent, we solve this problem. we solve execution environment problem, EVM slash execution environment problem, because developers can rely on the entire execution environment. They can represent all standards using one special smart contract, and this is the basic concept that you can do this. Regarding the performance, so we use LLVM. So LLVM produces quite efficient code base. It optimizes instructions a lot. And if you create your application using and compile it using LLVM, for example, to your Intel instruction set and execute on your computer, and then you instead of executing it on Intel, you replace it and run it as a WebAssembly. Of course, you get additional computation overhead, but you compare this overhead with your native execution, with your Intel instruction set, with your hardware optimized instructions. But if you start comparing, for example, execution of EVM instructions with, for example, WebAssembly instructions, you will get like 1,000 times performance increase, because it's much more efficient to execute to optimize your WebAssembly execution compared to trying to optimize, for example, EVM execution.
Mhm.
And we know that EVM is the problem because we need to run emulator of EVM, and we don't like emulation. Instead, we create ahead of time compilers, and we translate EVM to WebAssembly optimized representation that creates a special binary bundle that describes how to execute EVM without this additional emulation overhead. So more natively. Of course, you have this stack computations overhead, but this is the nature of EVM. You cannot avoid this.
Yeah, awesome. And it hurts my soul a little bit to cut this conversation off, but I think an hour is all the time that we have for attention span in crypto. But I think there's so many interesting further conversations we can have, whether this is about interoperability and solving this at the execution environment level, as opposed to with all these third-party projects, or just how we get to supporting more modern applications, and on and on and on. But I will cut us off here. Kevin, Rushi, Dimitri, I just want to say thank you just for your time and your insight, and just a really fresh perspective on what's going on at this level of the stack that really isn't noticed except for by I don't know, the 30 people that actually develop apps in this space, and not just gamble on them. So you guys, thank you so much. Much appreciated. And audience, have a good rest of your day.
Thanks for having me.
Thanks, appreciate it.